All right, here we go. Number 1. What is going to be the next number in our sequence? There's something. There is a pattern. They all have patterns, Mason. It'll be 4 over 5. Yes. Yep. What's the next number in number 2?
15.
Oh, sorry, guys. It'll be 15. Okay. Oh. There we go. Brain connect to hand. Good. How about number 3? 25. Yeah. And number 4? Negative 5.4. So they all have patterns. They're not all arithmetic, but there is a pattern happening. Okay? To make it arithmetic, it has to be adding or subtracting the same thing each time. Is that happening in number 1? No. Both pieces of the fraction are increasing by 1, but we're not adding the same number each time. Fractions are kind of hard to see. If you want to change these to decimals, that's 0.5. Then we have 0.67. Then we have 0.75. So if you look at it this way, you can tell you're not adding the same thing each time. Okay? Number 2. Is number 2 arithmetic? Yes, it is. So what's my common difference? We added 4 each time. Number 3, is it arithmetic? No, it's not. But what was the pattern? Kind of. It's the pattern of squares also. Yeah, so there's 2 things happening. You are adding the next odd number, technically, but you are also going through the pattern of squares. 1 squared, 2 squared, 3 squared, 4 squared. That's also happening. But yes, you're also adding 3, 5, 7, 9. That's happening. All right, number 4, is that arithmetic? Yes. So what's our common difference here? Going down 1.1. Good. So we're still in the world of arithmetic. Okay, we're still doing that today. We're going to still do it tomorrow. Today we're doing more exploring, and we're like creating the equation based off of word problems. Okay, based off of a word description. So we're not going to be as exact today. It's going to be more of what would happen if situations. Okay, so we're going to go through it. We're going to kind of remember what we did yesterday along the way and use that to help us create our formulas. So our first page is all about Sydney. Okay, Sydney is training for an upcoming half marathon and plans to run 4 miles on the first day of training and increases by 1/5 of a mile each day. This is very much like what we did yesterday. So how many miles does Sydney run on the first 4 days of training? So on day 1, how many miles does she run? She runs the 4 miles, right? What does she run on day 2? How many miles? 4 and 1/5. Yeah, she took her initial 4 and she's increasing it by 1/5. How many miles is she running on the 3rd day? 4 and 2/5. Good. And then the 4th day? 4 and 3/5. All right, so that's if we know everything. Okay. I can just add the numbers together and move it forward. Awesome. But what if we're missing something? So what if I don't know what she started with? Okay. Suppose her initial running was A miles. Okay. But we know she's still increasing by 1/5 each day. How can I represent how many miles she runs on day 1? Just an A. Okay. How about day 2? A plus the 1/5. Good. Day 3. Yeah, so we continue to add. And then on day 4, A plus 3/5. Good. How is each term in the sequence related to the previous term? What did we do to move forward each time? We just added that 1/5. Yes. Took our previous day and we added 1/5 to it. All right, now let's suppose we have our initial distance is A miles, but instead of saying she's increasing by 1/5, she's increasing by D miles. We don't know what it is. Where D is bigger than 0, it means she has to do something, right? We can't have D equals 0. She's not gonna take a day off. Not allowed. She has to do something. So now how can I represent the first 4 days? Well, day 1 is still going to be what? Day 1 is still A. We still start with the A miles, whatever they are. So now how do I represent day 2? Just D? A plus D. Good. My initial plus my distance. All right. How about day 3? Yeah, A plus 2D. Good, because we have our initial value, right? And it's been 2 days. So she's added that extra distance, whatever it is, twice. So yeah, A plus 2D. So day 4 is going to be A plus 3D. Good. Day 1, day 2, day 3, day 4. So my initial miles plus 3 extra of whatever the extra miles she's increasing by. Good. Excuse me. So yeah, this is more generic than yesterday. So how could I find the distance for any day? For the nth day. Remember, n means any. I got the pattern down at the bottom still. Excuse me. How do I find the nth distance? Look at our pattern. How can I write it for no matter what day it is? A plus ND. N minus 1D. Good, because technically there's a 1 right here, right? 2, 3. So the 4th day was 3D. The 3rd day was 2D, right? Because we added on to what was happening before. So in general, no matter what day she's running, I could do my initial amount plus n minus 1D. Or you can say d times n minus 1. Technically that is the same thing. I don't care how you write it. They are the same. Okay, so let's take this information now. It wants me now to write 3 equations. It wants me to write the equation for f of 1, f of 2, and f of n. And I believe, does it say specifically? No, okay, it does not tell you what kind of equation, like explicit versus recursive. Okay, so we just did, remember this is kind of tying in yesterday with notation. F of 1, f of 2, f of n, that's the same thing as finding a certain day. So we just did f of n, technically. For any day, we can use the a plus n minus 1d. Okay, we just did that. How can I write an equation for f of 1? What did I just replace in my equation? I changed the n. So this becomes 1 minus 1, which is what? 0. And what's 0 times d? 0, yeah. So we have just a left over. Does that make sense? On day 1, did she only run a miles? Yeah, that's her initial value. Makes sense. How can we use our formula for my second day? Change my n to a 2. Yeah. So what is 2 minus 1? 1. And what's 1 times d? 1d. Does that make sense? On her second day, did she add the distance to her initial amount? Yes. These equations are making sense. What kind of functions are these? Meaning if I were to actually graph them, what is it? They are linear, yes, because we're starting at a certain amount and we're growing by the same amount each day. So wherever we're starting, we are increasing by the same amount. It's going to end up being a linear function. Yes. Do you think every arithmetic sequence is going to be a linear function?
Yeah.
Yes, because we're adding and subtracting the same thing every time, right? To add and subtract the same thing, that is slope. That is forming a line. So every arithmetic sequence is going to be a line. Okay, so again, this is arithmetic, so this is where we are remembering from yesterday. All right, let me get my paper. Okay, so we had an arithmetic sequence. That's where we take what we already know and we add and subtract the same thing to it. That's what that means. There were two formulas we did yesterday. Let's remember them. We had the explicit formula. Who remembers what that formula was? What did we need for the explicit?
Everything equals the first term plus the different times the number of the term minus 1.
-1. Good. Yes. So we needed the first piece and our difference. Yesterday, I believe we wrote it more in this format. Again, it is the same thing. Our first term and our difference. The other thing we used was recursive. What was our recursive formula yesterday? Right, take my previous term and add the difference to it. Good. Where D is our common difference, and this guy represents the previous term. Good. All right. Now we're going to apply it to a problem, okay? So we're going to use information given to us to create a formula to represent anything. So they're going to give us specifics to help us get started, and then we can create a formula that represents any situation with that problem. All right? You ready? Some real world stuff happening. I know, get excited. Here we go. Hans starts a new job at the Millennium Shack. His boss starts employees at a minimum wage of $7.25 an hour. However, the boss believes in rewarding good employees for good performance. If employees are on time each shift and receives no customer complaints, the boss guarantees them a 10-cent increase each quarter. Let's write a function that shows an employee's possible hourly pay after n quarters. Okay, so in order for us to create this function, we got to go some details first, okay? What was Hans's first, his initial hourly rate, his first day of work? $7.25. Does anyone get the reference here? Hans, Millennium? No? Star Wars, there you go, yes. All right, so let's assume that Hans did a great job after his first quarter on the job, so he gets his 10-cent increase. So what's his new hourly rate going to be? How did you get $7.35? You added 10 cents to his initial. Good. Again, seems silly. We talked about yesterday. We're starting slow, building up. We're going to pretend like you've never done this before. Because some of you actually haven't. Assume Hans did a great job after his year of employment. Use an arithmetic sequence to represent his hourly rate that first year. Okay, so what's his very first amount? The $7.25. Good. After quarter one, we just said he's making how much? $7.35. How about after quarter two? $7.45. After quarter three? $7.55. And I should have gone one more to represent a whole year because there's 4 quarters in a year. So at the end of the year, he's making what? $7.65. So after a whole year, he has how much of an increase? After the entire year, how much did his pay increase? What? 40 cents an hour. Good. Makes sense, right? There were 4 quarters. He got the 10 cents each quarter, 40 cents. All right, so now we're going to write the explicit formula for this equation, and we're going to write the recursive formula for this equation. Okay? So let's start with the explicit formula. So that's the one where we need our first amount and then our difference. So this is for any quarter. N means any quarter. What was our first amount? 725. What was our difference? The 0.10, the 10 cents. Yep. So we're going to represent that as 725 plus 0.10 n minus 1. Today is all about creating the functions. All right, now let's write the recursive formula. So remember, that's when I have to reverse. We have to use the previous term and add my difference. So the only thing I change here is the D, and my D is what? The 10 cents. Good. So then after you create your equations on your homework, so you'll do those steps. You'll figure out the pattern. You'll create your two formulas, explicit and recursive. And then it's going to ask you to use those formulas in a certain way. Okay? So you have both of them there, and then you'll use them to answer more questions. Like in this one, if I said how much money is Hans making after 3 years on the job, you could use one of those to figure it out. Question, would I plug in 3 for n? No, what would you actually plug in? Good, 12, because there's 4 quarters in the year. Beautiful. We good? Any questions? Hopefully pretty straightforward. Okay, it's a little bit more vague than yesterday, but you're finding patterns, you're creating the equations. All right?